What's up everyone and welcome. In this episode we're going to talk about a secret agent living in the Azure ecosystem found by cybersecurity company Wiz.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
Supply chain cyberattacks have disrupted everyday life and they've dominated headlines this year. One of the biggest challenges in preventing them is that our digital supply chain is oftentimes not transparent. If you don't know what's hidden in the services and products you use every day, then how can you manage the risk? Wiz's research team recently discovered a series of alarming vulnerabilities that highlight the supply chain risk of open source code, particularly for customers of cloud computing services. The source of the problem is a ubiquitous in the Azure ecosystem, but a ubiquitous but little known software agent called Open Management Infrastructure, or OMI, and it's embedded in many popular Azure services, so provided by Microsoft. When customers set up a Linux virtual machine in their Azure cloud, the OMI agent is automatically deployed without their knowledge when they enable certain Azure provided services. Unless a patch is applied, attackers can easily exploit these four vulnerabilities to escalate to root privileges and remotely execute malicious code. For instance, I don't know, encrypting files for ransom maybe? Wiz named this quartet of 0 days, "Oh my god!" because that was their reaction when they discovered them. They conservatively estimate that thousands of Azure customers and millions of endpoints are affected. In a small sample of Azure tenants they analyzed, over 65% were unknowingly at risk. On Tuesday, Microsoft issued the following CVEs for "Oh my god!" and made a patch available to customers during their Patch Tuesday release. CVE 2021-38647, which is an unauthenticated remote code execution as root vulnerability with a severity score of 9.8. CVE 2021-38648, which is a privilege escalation vulnerability, severity score 7.8. CVE 2021-38645, another privilege escalation vulnerability, also severity 7.8, and CVE 2021-38649, a third privilege escalation vulnerability with a severity score of 7.0.
This Sweetie Pitty went to market. This Sweetie Pitty stayed home. This Sweetie Pitty had roast beef. Well, what do you know? I ran out of pitties.
Now, all users are, of course, urged to read and incorporate mitigation steps set forth by Microsoft. If you want to look at what Open Management Infrastructure is, why it's a problem, well, first, it is an open source project that was sponsored by Microsoft in collaboration with the Open Group. Essentially, it's Windows Management Infrastructure, known as WMI, but it's for Unix and Linux systems, not for Windows systems. So open source Linux is the operating system of choice on the modern web, and it has become dominant in Azure in recent years. So although Azure belongs to Microsoft, and Microsoft has Windows servers, so many clients are using the Linux virtual machines that they provide, and in turn, they come along with this open management infrastructure when you deploy specific services with these images. So OMI allows you to gather statistics and sync configurations across your environment when it comes to Linux machines. Thanks to the ease of use and abstraction that OMI provides, it is used extensively by Azure services, including Open Management Suite, Azure Insights, and Azure Automation. When users enable any of these popular services, OMI is silently installed on their virtual machine, running at the highest privileges possible. This happens without customers' explicit consent or knowledge. Now, when you launch a server, you simply click Agree to Log Collection during setup, and they have unknowingly opted in to have OMI installed on your Linux system. The OMI agent runs as root with the highest privileges. Any user can communicate with it using a Unix socket or via an HTTP API when configured to allow external access. As a result, the vulnerabilities they found would allow external users or low-privileged users to remotely execute code on target machines or escalate privileges.
Yikes! And away! 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 Yikes! And away!
3 of the 4 0 days found by researchers are privilege escalation vulnerabilities, as we saw. They enable attackers to gain the highest privileges on a machine with OMI installed. Attackers often use such vulnerabilities as part of a sophisticated attack chain after gaining initial low privilege access to their targets. The fourth and most serious vulnerability, with a severity score of 9.8 out of 10, allows remote code execution. Some Azure products, including configuration management, expose an HTTPS port 5986, for interacting with OMI. Now that's what makes RCE possible. Note that most Azure services that use OMI deploy it without exposing the HTTPS port, so not all systems are automatically prone. The researchers noted that this is a textbook remote code execution vulnerability that you would actually expect to see in the 90s. It's highly unusual to have one crop up in 2021 that can expose millions of endpoints. With a single packet, an attacker can become root on a remote machine by simply removing the authentication header. It's that simple. Thanks to the combination of a simple conditional statement coding mistake and an uninitialized auth struct, any request without an authorization header has its privileges default to UID equals 0, GID equals 0, which is root. This vulnerability allows for remote takeover when OMI exposes the HTTPS management port externally, again ports 5986, then 5985, or 1270. This is the default configuration when installed standalone and in Azure Configuration Management or System Center Operations Manager. Fortunately, other Azure services, such as Log Analytics, do not expose this port, so the scope is limited to local privilege escalation in those situations.
Hey, there's something awfully screwy going on around here.
Azure customers on Linux machines, which account for over half of all Azure instances according to Microsoft, are at risk if they use any of the following services or tools: Azure Automation, Azure Automatic Update, Azure Operations Management Suite, Azure Log Analytics, Azure Configuration Management, and Azure Diagnostics. Now that's just a partial list. In addition to Azure Cloud customers, other Microsoft customers are affected since OMI can be independently installed on any Linux machine and is frequently used on-premise. For example, OMI is built in System Center for Linux, Microsoft's server management solution. Microsoft dispatched this issue as of September 14th. So, how do we control and monitor what open source applications our systems rely on? One of the benefits of open source is that it's easy for developers to just grab some code from different projects, mix it all together in open source and proprietary software. As a result, sometimes bad open source code can wind up in an enormous range of products and services, inadvertently becoming a single point of failure. Because you don't know what code is running in these underlying open source projects, your systems can be at great risk. We need to integrate better monitoring, testing, and management of different pieces we integrate into our projects to power our own solutions. Only then can we have a better understanding of what is under the hood within our software and be able to react sooner when a vulnerability such as this is found. With that, I say thanks for watching. Don't forget to share and subscribe if you haven't. And smash the bell if you haven't. And I'll see you in the next episode. Take care.